Hello class, our final project focused on investigating gender bias in machine learning models dealing with text data. We'll start with a brief video to give a feeling of what gender bias actually is.
I'm not on board with the direction this decision is going. We're chasing a market that doesn't exist. It's as if we're completely ignoring the data.
We showed videos like this to more than 11,000 subjects. Many observers judged this forceful woman as incompetent and a poor leader. But when a man did the same...
I'm not on board with the direction this decision is going. We're chasing a market that doesn't exist. It's as if we're completely...
This man wasn't judged as harshly as the woman.
As we've seen in this video by the BS guys, gender bias is unfortunately amongst us in our everyday lives. Since machine learning language-based algorithms are based on data generated from humans, like conversation, documents, news articles, etc., the bias inherent in human society is reproduced by our algorithms, consequently biases the results. Common practice for representing textual data is the use of word embeddings, which essentially represent the word numerically in a vector of a few hundred dimensions. The word vec for soccer is shown below to visualize an example. The great thing about this representation is that it was trained on such a huge corpus of documents that it captured semantical meanings of each word. Although this is indeed great for text-mining tasks, this is also where the problem of gender bias arises.
In order to reduce gender bias in word embeddings, we selected 9 pairs of gender-specific words and 100 occupations that should be gender-neutral. For example, nurse is an occupation both men and women have, however is more associated to a woman's job, and similarly a janitor can either be a male or a female, however is more associated to a male. Since the only difference in meaning between the gender-specific word pairs are the actual gender it is referring to, we implemented PCA to identify 7 most significant dimensions which we defined as the gender subspace. These are our results, where as can be seen, the dimensions chosen each have a gender connotation of over 5%, where all other dimensions had less. We then isolated the gender subspace in the gender bias occupation words and performed what is called hard debiasing. What this method does is takes the mean of the gender subspace from the gender-specific words and substitutes it into the gender-biased words. In order to show the results of the gender bias reduction, we define a she-score and a he-score by taking the dot product of these word vectors with each occupation i's respectively. These are the results before our gender bias reduction implementation, highlighting 2 bias occupations for reference, and these are the results after the gender bias reduction, where all of them have been shifted towards the gender-neutral diagonal of the she and he scores.
So, as our results illustrated, we successfully reduced gender biases which were inherent in the commonly used word embeddings for textual data. When implemented by machine learning programs applying job applicants' CVs, loan approvals, and so many other tasks using the industry today, including closing the gap of gender inequality in our society. Thank you.